Good day, everyone. By the way, my name is a.callano, and I will discuss today the structural components and general principle of flexible pavement. So first, let's define what is pavement. So it's the structure which separates the tires of vehicles from the underlying foundation material. The latter is generally the soil, but it may be structural concrete or a steel bridge deck. So pavement, guys, this is the hard surface of the road. So in the on the picture, that is an example of a pavement. So type of pavement, we have two types of pavement. The first one is the rigid pavement. The second one is the flexible pavement. So rigid pavement is usually constructed of Portland cement concrete such that it acts like a beam over any irregularities in the underlying supporting materials, while flexible pavement is usually constructed of bituminous materials such that they remain in contact with the underlying materials even when minor irregularities occur. So, flexible pavement usually consists of bituminous surface underlaid with a layer of granular material and a layer of suitable mixture of coarse and fine materials. Types of flexible pavement. So we have three types of flexible pavement. The first one is conventional flexible pavements. Second is full depth asphalt pavements. And the last one is the contained rock asphalt mats. So conventional flexible pavements are layered systems with high quality expensive materials are placed in the top where stresses are high and low quality cheap materials are placed in the lower layers. Full depth asphalt pavements are constructed by placing bituminous layers directly on the soil subgrade. This is more suitable where when there is high traffic and local materials are not available. Contained rock asphalt mats are constructed by placing dense or open graded aggregates layers in between two asphalt layers. Modified dense graded asphalt concrete is placed above the subgrade, will significantly reduce the vertical compressive strain of on soil subgrade and protect the surface water. Components of flexible pavement. So we have four components of flexible pavement. The first one is the subgrade, which you can see that on the lower part. And the second one is the subbase. The third is the base course. And the last one is the surface course. So subgrade is usually the natural material located along the horizontal alignment of the pavement and serves as the foundation of the pavement structure. So it is necessary, guys, to treat the subgrade material to achieve certain strength properties required for the type of pavement being constructed. Next is sub-base. So the sub-base component consists of material of a superior quality to that which is generally used for subgrade construction. Sub-base is located above the subgrade. So next is the base course. This course usually consists of granular materials such as crushed stone, crushed or uncrushed slag, crushed or uncrushed gravel, and sand with respect to their plasticity, graduation, and strength. So, base course is located above the sub base, and actually, guys, base course if the sub-base course is not used, then we will place the sub-base above the subgrade. The specifications for sub-base materials usually include more strict requirements than those for sub-base materials, particularly with respect to their plasticity, graduation, and strength. So next is surface course. Is the upper course of the road pavement and is constructed immediately above the base surface. So the surface coarse and flexible pavement, guys, usually consist of a mixture of mineral aggregates and asphalt. It should be capable of withstanding high tire pressures, resisting abrasive forces due to traffic, providing a skid-resistant driving surface, and preventing the penetration of surface water into the underlying layers. So the thickness of the surface can be vary from 3 inches to more than 6 inches depending on the expected traffic on the pavement. So soil stabilization is defined as chemical or physical treatments which increase or maintain the stability of the soil and improve its engineering properties. So it is a process, guys, by which a soil's physical property are transformed to provide long-term permanent strength gains. The procedure for stabilizing soil with cement involves first pulverizing the soil. So for the soil to be stabilized, guys, the soil should be pulverized thoroughly to facilitate the mixing of the cement and soil. So when the existing materials on the roadway is to be used, the roadway is scarified to the required depth using a scarifier attached to a grader. The next one is mixing the required quantity of cement with the pulverized soil. So this is the mixing of soil and cement. In the mixing process, guys, this is done to determine the amount of cement to be added to the soil by conducting laboratory experiments, whereas to determine the minimum quantity of cement required. So the required tests are described by the Portland Cement Association. These tests generally include the classification of the soils to be stabilized using the American Association of State Highway and Transportation Officials Classification System. The third one is compacting the soil cement mixture. So it is essential that compaction of the mixture be carried out before the mixture begins to set. The soil cement mixture is initially compacted with sheep foot rollers or pneumatic tired rollers when the soil, for example, is very sandy, so cannot be effectively compacted with sheep foot um, roller. So the last one is curing the compacted layer. So the moisture lost in the compacted layer must be prevented before setting is completed because the moisture is required for the hydration process. This is achieved by applying a thin layer of bituminous materials. So that is the procedure for stabilizing soil with cement. So that's all, guys. Thank you for listening. Bye bye.